So dear students, we are going to see the transformer chapter. So what is transformer? Transformer is a static device which changes the voltage with respect to current, keeping frequency and power constant. Primary is connected to supply and secondary is connected to load. So the transformation ratio is what? So power should be constant, therefore V1 I1 is equal to V2 I2. Therefore V1 by V2 is voltage ratio and voltage transformation ratio is V2 by V1, E2 by E1, N2 by N1 and I1 by I2, that is equal to K, that is transformation ratio. Voltage equation of transformer single phase. So average EMF is phi m by 1 by 4 F and ERMS will be 1.11 E average, that is equal to 4.44 F phi m N. There are two types of main transformers: construction, core type and shell type. Their windings are inside, and in core type transformer windings are in outside, that is used for HV, and shell type transformer are used for LV, and bare type transformers are used for. So there are two types of losses in transformer: iron losses, that is hysteresis, which is caused by the magnetic flux leakage, and eddy current loss, which is leakage of eddy currents in the circular path winding I square RT, that is temperature leakage also, which is covered by using silicon steel stampings, laminations. Copper loss I square R. If half load is given, then current is changing by double. For maintenance of transformer, that is winding and oil temperature, you have to look out cable box check and load and voltage variations, relay and alarm signals, insulation resistance, oil level, earth resistance, check out, and breather dehydration, that is in brown, silica gel, that is blue, which is the respiratory system of transformer. And the cooling system, that is natural cooling, oil blast cooling, minimum oil blast cooling, forced air blast cooling, water cooling. So these are the cooling systems. Oil sluicing, so these are the maintenance you have to carry out within months, 7 days or 6 months, regular checkout routine. So main parts of transformers: tank, bushings, tap changer, conservator, breather, which performs the breathing respiration system, explosive vent, Buckles relay, which gives the signals when the temperature varies. So the bubbles of hydrogen gases trips the Buckles relay and circuit breaker gets signal and trips the whole system. Temperature gauge, transformer oil, that is dielectric strength, which is measured in 1 minute for 30 to 50 kV. So for that we are having this setup. That distance should be 4 centimeter for that. Parallel operation of transformer is performed when terminal voltage, phase sequence and frequency should be same, and that is not performed in star star and star delta connection. Then Scott's connection is used for converting 3 phase to 2 phase. So there is tertiary transformer and main transformer, and the tappings are in the 86.66, and that is 2 by 3 and 1 by 3, that is tappings. And from transformer 1 we are getting output and phi 1, and from transformer 2 we are getting phi 2, that is 2 phase from 3 phase. So these are the circuit diagrams from which Scott connection being performed. Polarity test. For polarity test, if the polarity is same, then voltage shown by voltmeter is double reading. If the polarity is different, then voltmeter shows 0 reading between two transformers. Transformer rating is kVA, not in kW, because due to no load applied to transformer, therefore there is no kilowatt ratings. And power transfer in voltage and ampere, so that's why kVA. So at no load condition, the phasor diagram is given like that. I0 is square root of windage current and magnetizing current square. And on load condition, so I1 will be, and here phi 1 and phi 2 will be same. Open circuit test, copper loss find out. So in the open circuit test, we are performing the open circuit at the secondary terminals, which is high tension winding. So due to open circuit, resistance is infinite and current is 0, I2 is 0, therefore copper loss will be here 0, and the remaining, that is core loss, which is denoted by wattmeter reading. And in short circuit test, we are finding out copper loss, and here you can see we are applying 5% of V1, that is supply voltage, is given to the primary side in the ST winding. So you will find there is induced EMF is 0 due to low voltage, therefore core loss is 0, and I2 square R, that is copper loss, is denoted by wattmeter. Frequently we are calculating the transformer efficiency, that is output upon input multiplied by 100, output upon output plus loss multiplied by 100, and all day efficiency is kWh, output upon kWh input multiplied by 100 in 24 hours, that is all day efficiency. Voltage regulation is very necessary for calculations, that is no load voltage minus full load voltage upon no load voltage multiplied by 100. So there are two types of connections, star connection and delta connections. So in these star connections, we are shorting the U1, V1 and W1. And in delta connections, starting terminal gets connected with the ending terminal. So U1 gets connected with the W2 and U2 gets connected with the V1, V2 gets connected with the W1. So in this way connections are being made for delta. In star connection, VL is equal to root 3 VPH and IL is equal to IPH. And in delta connection, VL is equal to VPH and IL is equal to root 3 IPH. So at last, we are going to see, the operating principle of transformer, as soon as the primary winding is connected to the single phase AC supply and AC current starts flowing through it, which induces the voltage induced EMF in primary winding. The AC primary current produces an alternating flux in the core. Most of the changing flux get linked with the secondary winding through the core. The varying flux will induce voltage into the secondary winding according to Faraday's law of electromagnetic induction. Thank you very much.